Hello. Today I'm going to show you all the angles on a pair of parallel lines. So first off, let's draw the lines. So parallel doesn't have to be horizontal and vertical, as long as the two are parallel to each other. So the angle they're at makes no difference. So sort of if I had them like this as a horizontal, spin them out to be vertical, or any angle in between, it's the same rules. It's all about how their relation to each other, not their relationship to the world outside them. So we have our two parallel lines. We indicate those with two arrows. And then we draw a intersecting traversal. This is just a line that crosses both, intersects. Think intersecting, intersects, and traversal, traverses from one to the other one. So the only thing that we need to know before we start this is the fact that on a straight line, angles add up to 180 degrees. So if we just have a straight line, one line coming off it, this angle and this angle will add up to 180. It's the only factor we need. So what we can do is we can see where we have some straight lines. We have this lower parallel line, which is a straight line. All our lines here are straight. So what we can see is that we can have this angle and we can also have this angle. And we know, because this is one straight line, that these two must add up to 180. So what I'm going to do is I'm going to fill in one as red and the other as blue. And then we're going to try and basically fill in every other angle as either red or blue. So all the blue angles will have the same value. All the red will have the same value, and we know that one blue plus one red adds up to 180. So straight away, we can see along this straight line up here, that this angle plus this angle must make 180. Well, we knew that the red plus the blue makes 180, so red plus another blue must make 180. And just carrying on that little pattern, we'll see the same thing at this angle over here. We can look at any of these straight lines, either this one across here or this one down here, and see that this one should be red as well. So that gives us our first little fact, really. Our first fact that we want to take away from this is something called opposite angles. And that tells us basically what we have here, that these two angles, the blue ones are the same and the red ones are the same. So they're called vertically opposite. Vertically not because it's horizontal and vertical, but vertically as in it's a vertex. So what we call sort of a corner you can think of as in a shape, we call a vertex. So these two angles are vertically opposite. They're on the opposite side of the vertex and they're always the same. Always the same. So always equal. So the next little fact we need to know is kind of, it's not really a fact I suppose, it's how you think about this. So imagine that we were stood on this point here and facing to the right hand side. And we walked to this vertex, down to this vertex and back along this direction. So we started off facing right, we ended facing left. So the entire angle that we've turned through as we stand here facing to the right, turn to face down and then turn again to face left, the total angle we turned through was 180 degrees. And the angles we actually passed through was this one. So I think we're facing right and we turned to face in this direction. We've gone like that. And then we were facing this way and we turned to face right. So that was going to be this blue one down here. So what we can see is that this angle plus this angle must be 180 because we were facing right, we turned through it, got down to here and turned through that, and we turned through that angle and that angle, they made 180, so therefore they must add up to be 180. So using our colours, this one was blue, this one must be red up here. And what we can do is, there's no real difference between this vertex and this vertex. So we can see that all the arguments we've used to fill in the rest of the colours here are going to be the same up there. So I'll just go fill those in. So we'll have again red opposite. And blue will make up the other two angles in between. I did the red ones big at the top and the red ones little at the bottom. That has nothing to do with the angles, the actual sort of the size of my semicircle or my part circle, my sector I suppose you could call it. The size of the sector makes no difference, it's all about the colours. And what we can see is the colours match up. So we've got red sort of in this one here and red in this one here and blue sort of across that way and across that way. They're going to be the same. This is always the case, that the angles that appear down here are exactly the same as the ones that appear up here in the same position. So the bottom right and the bottom right will always be the same. The top left will always be the same. Bottom left, top right, always going to be the same. So we can fill in the other two facts that we get from this. So the first one is known as the F angles, but the proper name for it is the corresponding angles. Corresponding So this is basically why we use the F symbol, is it's the angles that look like an F. So with the two parallel lines as the two crossbars and the other one crossing over, you can see we get like this sort of idea. So it's basically saying like these red ones are the same, these blue ones are the same, this red ones are the same, and this blue one's the same. So what we were saying about the matching one, so the bottom left and the bottom left, this is basically saying that the bottom left and the bottom left, so the corresponding angle, the angle in the same position on each vertex, are going to be equal to each other. The other one we can get then is something called Z angles, which is the alternate angles. So it's given us the other position basically. If we think about like, let's pick this just blue one in the bottom left. The opposite angle tells us this one's the same. The corresponding angle tells us that this one is the same, sort of the bottom left up here. And the alternate angle then would tell us that this one's the same. It looks a bit weird from the angle we get at here. Normally you'd see it on the inside angle, so you'd have a Z shape, hence the Z. So looking across, we would have sort of this Z here, so right, down and right again. So right, down and right again. So you can see this one inside the Zs. So these blue and these blue. And similarly, you can do the other side, and these red and these red. So yeah, these are all the facts about parallel lines and the angles on them. It can be useful to think about all of these three separate things, but it can also be more useful sometimes to think about them as a whole, and the fact that it just completely matches up here. And these are basically telling you the three positions where the other one would appear. So if we think about this top left one, the opposite tells us it's down here, the corresponding tells us that this one is the same, and the alternate tells us that this one is the same. So these three facts tell us the three different locations of the same angle, basically. So yeah, that's it. Thanks.